Good morning, everyone. Thanks for your time to participate in today's technical sharing. And before I deliver this sharing, let me have a quick introduce by myself. My English is a cover who represents the solution engineer of the BadHaus team. And today's sharing is about a key component of modern data pipelines. Through the session, I will explore the critical aspects of the data lake import process and discuss the best practice that can ensure a seamless and efficient data ingestion experience. And in addition, I will also explore some benefits about the Lakehorse, including the ability to provide a single source of truth, how data will be ingested into the data lakes across different data sources. And I will compare, some advantage and disadvantage of traditional data warehouse, data lakes, and the Lakehorse solution. And furthermore, some deep dive into the key considerations for the data lake import, including the data formats, data integration methods, and data transformation technologies. Okay, so let us start. Okay, sorry, some network latency. And some of you may have heard about the Lakehorse. So let's take some time to recap the three stages of the data analytics evolution. The first one is the traditional data warehouse, the data lakes, and the development of the Lakehorse. Okay, so as you can see from the left to the right slides standing for the trends in the data analytics development since age 98 for now. The advantage and the disadvantage of the traditional warehouse is that, as you may know, the process the high performance querying. The data house through the optimizing and the indexing can execute the complex the queries and aggregation operations, providing the faster response time for the lookup queries. But on the other hand, the coins if the original database schema has changed. So we need to sync the table schema we call DDL with the data warehouse again and reload the data. So the second issue is the data silos, where the data has to be replicated elsewhere when other data warehouse needs to use it. So this is the coins and the points of the traditional data warehouse. So how about the data lake? So the data lake, I think is the great advantage is elastic and the flexibility. Data lake can store the various types of the data, including the structure, semi-structure, and unstructured data. So, and also the data warehouse like OLEP can directly read the data from the data lake by the external table. So you do not need to import the data before you use it. You can directly check or query the data while stored on the data lake. So this is the advantage of the data lake. And on the other hand, the disadvantage is, as you know, lack of the unified metadata management. If source data changes, so the customer has to refresh the table schema, and yes, so which meaning once the source DDL changes, the table on the lake, the data lake cannot automatically sync any change on the source side. So this is the advantage of the data lake. So for now, and the Lakehorse is the integration of the data lakes and the data house together, which combines the flexibility of the data lakes with the analytical capabilities of the data warehouse. So I think some advantage is very obviously that the first one is for the absurd. So which meaning for the traditional one, the data warehousing, the data cannot be updated or deleted. So if you want to do that, you have to rewrite the data with the new change. But on the Lakehorse, with the absurd functionality, data can be updated and changed. So, and the second advantage is that time travel. If we want to choose a point in time from the past, and we can get the state of the data from that time, regardless of the current status of the data. And the most important advantage is the schema evolution. We call schema evolution, which enable the Lakehorse to automatically add new columns or reflect the source DDL change when those the columns belong to the original database. So all these are common basic comparisons among the traditional data warehouse and the data lake, and even for the data lakes. Okay, so let's take a look at the current main Lakehorse solutions from the main cloud vendors offered. Currently, most cloud providers offer solution based on the object storage as a unified data foundation, and also the data lake formation, we call DLF in short, provides the data ingestion, data cleaning, and the query capabilities. For data ingestion, Flink CDC, like John mentioned, Flink CDC is change data capture. So this technology is used to capture data changes in the source database for full and incremental data synchronization. And data cleaning is typically performed use Flink or Spark for multi-table join or conditional filtering. And the data querying can be done in real time, like in the near real time, like Athena. So, and the catalog service will be handled by the Glue to store all the metadata of the table format and the physical partition mapping relationship on the S3 bucket. If you want to get the low latency required queries, we may use like Redshift or the OL or other OLAP data warehousing to get the result as soon as possible. And also, to query the data can be write to the data lake with some open formats like Avro, JSON, and Parquet. And let us see some the open source solution. For the open source Lakehorse solution, primarily we also used S3 object storage as the underlying data foundation. It is very similar to other cloud providers. However, we utilize the Apache open source projects like Hudi, Iceberg, or Delta Lake as the storage and the table format abstraction layer for some advanced features like time travel absurd and the order indexing. And the catalog can be managed using HMS called Hive Metastore or Hudi and the Iceberg catalog to maintain the mapping between the tables and the physical storage partitions. And for the data cache, we use the Aluxio, Apache Aluxio, as the data cache for accelerated data query. For the near real-time data queries, we can use the Flink SQL, Spark SQL, or even for the Presto. Well, real-time querying can be achieved using some solutions like Apache Doris or other kind of the cloud-based Lakehorse like the Databricks or even for the our product Bedhouse. And okay. How to choose a Lakehorse solution? Typically, the cloud provider solutions are suitable for the general users because they are easy to integrate and there is no need to infrastructure maintenance required, and all the components are pre-adapted by the cloud provider. On the other hand, open source solutions offer more features, flexibility, and the ability to customize and quickly obtain the new functionalities from the open source community. However, they require higher development skills and a dedicated operation team for the maintenance. Users should choose the solutions that best suitable based their needs. Okay, so for now, let us discuss how to use the data ingestion service to efficiently and conveniently extract data into the data lake. Let me introduce the entire data pipeline from the source to the OLAP data warehousing. The MySQL database is ingested into the Kafka through the Flink CDC, change the data capture. The reason for initially ingesting the data into Kafka instead of directly into Hudi is to enable multi-real-time tasks to reuse the data from the MySQL, thereby avoiding the performance impact on the original MySQL side, MySQL database side. Caused by the multiple tasks directly accessing the MySQL tables by reading the bin log. The data ingested into the Kafka through the Flink CDC is not only stored in the offline data warehousing from the ODS layer, but also processed through the real-time data warehousing data flow, including the ODS, DWD, and the DWS to the and finally to the OLAP database. The result data from each layer of the real-time data warehouse is also replicated in the near real-time to the offline data warehousing, ensuring the unified development, consistent metrics, and the centralized data management. On the right side of the slides, the SQL statements consist of the 4 parts. As you can see, some words marked in red. So the first part is simulates the creation of the source MySQL tables. And the second part, we will create the MySQL CDC table used for ingesting the data from the source MySQL table. The third part, we will create the Hudi table and the specific the S3 bucket storage path. And finally, the CDC data is continuously inserted into the Hudi table in the real time. As you can see in the last one, we will type insert into. This is the destination table on the Hudi, and select the language will be used as the Flink CDC to extract the data from the CDC to the Hudi. So this is the 4 paths to guide our customer or end user how to extract data from the MySQL to the Hudi. Sorry. Okay, so for this slides, meaning this architecture is the most popular in some scenarios, which having both streaming and batch data import into the data lake. It is particularly suitable when the data volume from the data source, like RDS retentional database, is relatively small. Because if you read the loss of the concurrency extract data or from the RDS, it will cause the business impact on the source side because lots of the connector will read the bin log to extract data from the source to the destination. And for example, if the data source is from the MySQL with the bin log enabled, and the QPS is in the minimal level, in a few, just like a few hundred. And in such case, this architecture provides suitable, stable solutions that not only enables end-to-end incremental processing, but also address the need of the ODS, DWD, DWM data ingestion into the data lake. This architecture or solution solves the key challenges. Firstly, it addresses the issue of the dual writes. In the Lambda architecture, where the data is first written to the Kafka and then ingested into the data warehousing, ensuring the consistency between these two sets of data can be challenging. Moreover, enable an exact once delivery in Kafka significantly reduce the throughput. So how can we ensure the consistency between the Kafka? Kafka is the data caching and the S3 bucket. So so may they consider consuming data directly from Kafka and synchronizing the data into the S3 bucket in a separate job. However, this approach would result in the double computing and storage resource, maintenance overhead, and the synchronization costs. Secondly, it resolves the query requirements of the intermediate layers like ODS, DWD with the data lake. It becomes possible to directly query the ODS, DWD using the OVL AP external tables. So you can imagine that if the data stored in the Kafka, it is very hard to directly read such data in the Kafka pipeline. So this can also resolve this problem. And why we need the backfill job in the step 3. So, sorry, because the first issue is that the Flink state expires due to some condition like the network issue and the memory limitation, which prevents the data being perceived in some location. As a result, the expired Flink state leads to unsuccessful job operations. The second issue is caused by incorrect Flink window or watermark settings, resulting the data loss. So this solution, we can help customer to resolve lots of the challenges during the data ingestion from the source to the data lake. So in this slide is a continuation of the previous slides. Take a look at this picture. If the data engineer wants to directly view the data in the intermediate layer, like ODS, DWD from the real-time streaming, we can use the OL AP query engines like Flink SQL or the Presto for the ad hoc querying. In comparison to store the real-time streaming like Kafka, it is very difficult to query the data during the intermediate layer. Yeah, and for the real-time data analytics, we can directly use the Apache CDC, Flink CDC to ingest data from the OLTP database directly into the OLAP for the real-time data analytics. And after that, the data set can be sync back to the data lake for the long-term storage retention policy required. Okay, for this slides, meaning in some IoT scenarios, the real-time streaming data is imported to the OLAP database. OLAP data warehousing through the Kafka or other like AWS Kinesis or AWMK services for the real-time data analytics and the data ingestion. And the data is periodically refreshed into the data lake. For now, lots of the OLAP database support data lake formats, such as Hudi and Iceberg by reading and writing the data lakes, and also can provide the users with a unified query format. And for the advantage of this solution, the first one is from reading the data lake to writing the data lake, which meaning we can also read the data by the external query. And also we can sync the data from the real-time data to the data lake as the long-term data store. And the data and the code data can be saved maybe on the data lake. And also the hot data will be saved on the OLTP HDFS side. And the second one is a unified query. The code data can be stored in the data lake, where hot data is also can be stored in the data lakes. And also for the SQL, we can use the centralized or unified SQL dialect to query the data, no matter the data is in the OLAP or in the data lake. Okay, so the last one is let us give the quick commercials. The BedHouse, the cloud data warehousing offered by the BedDance, will support the data lakes in Q3. And we most welcome everybody to try it out, and we will give the end user a free 30 days trial account. And also the BedHouse will support the Hudi and its related ecosystem. And in the future versions, we will support S3 and plus Glue. Glue is a metadata service. So BedHouse is a cloud native data warehouse that separates the storage and the computing in the different layers, offering the extreme performance and the pay-as-you-go payment. Okay, so and we also have the open source project called BedQuality. And also we most welcome everybody to participate in the POC and give us the feedback. Okay, thanks for everybody's time. Thanks.
Okay, thank you, Yaqi, for this insightful presentation. So now we'll be moving on to the Q&A session, and we'd like to invite everyone who has questions to submit them in the chat function. While waiting for questions to stream in, maybe I can start off with asking John a question. So what are the common challenges you face when designing a data pipeline, and how do you overcome them?
Thanks, Belle. So common challenges. Okay,
I think you're muted.
Am I still muted? I think I'm okay.
Okay, yeah. Okay, sorry, you can hear.
Okay. Yep. So common challenges. So I guess the first one is the understanding the purpose, because it's easy to get very complicated in your data pipeline. There are lots of tools, and just from the few that I introduced and Corva in his presentation introduced, you can see that there are some really complex ones to solve really complex use cases, and but if you don't need such complexity for your particular use case, then you don't want to overbuild. So I understand, and you also don't want to underbuild. So getting a feel for that range is very important at the outset. What's the data going to be used for? And the reality is that with data pipelines, there are multiple users of the data that you're going to be serving up. So understanding what decisions they need to make with the data. And it may not be the end user of the data. It may be the data analyst that needs to have this data is critical to constructing a pipeline that's going to serve and meet their needs. Once you understand the type of data, the complexity of the data, and the volume of that data, then you can start to work through those patterns for figuring out what are the best tools to apply. What are the best methods in order to achieve that? And then once you've got those bits right, then the rest starts to become a bit more mechanical.
All right. Thank you for sharing your insights. I see that we have one question from the chat group from Rocky. So he asks, how do you ensure data quality and integrity throughout the data pipeline and process? So would Yatsi or John like to take the question?
Okay, so data quality is always a challenge. There are two aspects. There's quality, and integrity, I think, is a more broader sort of question. Is actually, where does the data come from? Is it the system? Is it coming from the system of record? Because as we take data through the pipeline and transform it in different ways, it's no longer the same data that we started with. And if someone introduces a transformation that changes the nature of the data, then that's a problem for the end users. Well, the first thing, so in regard to integrity, some of that comes back to what's the data going to be used for, and do the users of the data understand what it is? That should be defined within the data catalog, so that people understand what it is that they're dealing with. Data quality is never going to be perfect. So one of the questions you need to ask is, how important is the data quality? For some things like personally identifiable information, it's about a person, it's about their health record, it's about their finances. That's critical. That needs to be checked and verified at different times. But very often when we're talking about a data pipeline, we're aggregating data up, and we're trying to actually mask the personally identifiable information. So we're often dealing with other types of information. The cleaning process is what when I mentioned the ETLT sub-pattern. That can be used to do some data cleaning, but you really want to understand what are the problems with the quality of data and what corrections might you need to make, might decide to make to the data, or will you just live with that? So data quality is a matter of having good pre-processing of the data as you ingest it, for the quality check as you go in, feedback from end users so that you can address problems with quality, but then also giving people an understanding of what quality they can expect from the data.
All right. Thank you so much for sharing your insights again.